Hello students, good morning. In today's class, we are going to start a new topic and the topic is correlation. Let me share my screen and then we will start the class. Correlation is a statistical measure that describes how strongly two variables are related and in which direction. That is, do they move together or do they move in opposite direction? For example, as a child's age increases, their height usually increases too. That's a positive correlation. Another example is ice cream sales go up in summer. So sales and weather are related. We will look at more such examples ahead. So as you can see here in this slide, there are two variables. So one variable is the age, and as age is increasing from 1 year, 2 year, 3 year to 5 year, the height also tends to increase. So there is a trend which is if you go from left to right, it goes upwards. It's a positive slope line that we can see. Okay. Now let's see here. Uh, this particular data is about sales of ice cream. So as you can see here, in the month of April, May, June, July, when it's summer season and temperature is high, the sales are also very high as compared to the other months. So we can see that there seems to be a correlation between the sales and the temperature. Now let's discuss another example. So another example could be uh, this one, where we are talking about two variables. One variable is number of hours studied per week and the exam score. In general, what would you expect is that if you increase the number of hours you are studying, very likely your exam score is also going to increase. On the other hand, if you reduce the number of hours you study, probably marks will also go down. So there seems to be a positive correlation between number of hours you study per week and your exam score in percentage. And in this case, again, the correlation seems to be positive correlation because as you increase the number of hours, your marks will also tend to increase. And this will be a positive slope line. So as you can see here, if we plot all these data points on a graph, we will get a trend line which is going upward if you move from left to right. Okay, now let's discuss another real world example. Another real world example could be the umbrella sales. So similar to our previous example where we discussed the sales of ice cream was influenced by the average temperature or influenced by the change in weather. Similarly, the sales of umbrella is also expected to get affected by weather, and in this case it will be affected by rain. So I hope you would expect that as the amount of rainfall increases, the sales of umbrella would also increase. So let's see this data in our next slide. So here you can see there are two variables. One is average rainfall and another is umbrella sales. And as you can see here, in these months, during these months, it is rainy season in Kolkata, and therefore the average rainfall is much more as compared to the other months. And very expectedly, the umbrella sales are also highest. So we can see that the two variables, which is one is average rainfall and another is sales of umbrella. So let's consider rainfall to be on the x-axis, on the horizontal axis, and sales of umbrella on y-axis. And you can see that as the rainfall will increase, the sales will also increase. So again, there is a positive correlation. So in this particular graph, we can see that this red color shows umbrella sales and the blue color shows average rainfall. These are moving together. As red increases, sorry, as blue increases, red also increases, and as blue tends to decrease, red also tends to decrease. These two variables are moving together. And when variables move together in the same direction, we say that the correlation is a positive correlation. Okay, now let's discuss a very important point, which is correlation is not causation. It is very important. So let me try to explain why do we say that correlation is not causation. See, just because two things happen together don't mean one causes the other. Let's take a very unconventional example. And that example could be just by luck, let's say in the past week, when ice cream sales were high, the car accidents also go up. Does that mean ice cream sales causes accidents? Of course not. It's likely that both happen on hot days when more people are outside. This could be pure chance, or this could be another factor, another third factor, which we have not considered so far, influencing both the variables. So we cannot say for sure just because we are seeing a correlation. And when do we say we are seeing a correlation? When we plot the data point and we say that data points are moving together in the same direction, it doesn't mean that one variable is causing the another variable, or the second variable is causing the first variable, and so on. So we have discussed car accident and ice cream sales example. I would like to discuss one more example. So let's take example of traffic congestion and pollution. So one variable is traffic congestion, another variable is pollution. So if there is more traffic, the pollution will be higher. And if pollution will be higher, people will probably dislike going outside in the traffic. So they will probably start taking more public transportation like metro, where they don't have to face the polluted air. So probably if pollution increases, people will start taking public transport and traffic congestion will be less. So as you can see here, there is a slightly complex interrelationship between these two variables. It's not very simple, right? And it's not like one is causing the another, or a second one is causing the first one. The relationship is much more complex. Okay, now we will talk about types of correlation. In today's video, we are going to talk about positive and negative types of correlation. Okay. So positive correlation, we will first discuss this. Okay, so let's first discuss a few examples. So the first example is height and weight. So as a child grows taller, as the height will increase, you will expect that weight will also increase. For example, weight of a 3 year old child, and when the same child grows to be 5 year old, the height increases, the weight also increases in general. Similarly, if you study hard, study more, spend more time studying, or spend more time honing a skill, uh, where it is very likely that your grades will improve, you will become better at that skill. So therefore, this is also an example of positive correlation. Okay, now we will discuss negative correlation. So far we have discussed positive correlation. Now we will discuss negative correlation. So let's take two examples. One example is the temperature and heater sales. So as the temperature goes down or it becomes more cold, what you will observe is that more and more people will start buying heaters. So let's try to plot temperature on the x-axis. So if the temperature increases, uh, and let's try to plot heater sales on y-axis. So if the temperature increases, more likely the sales of heater will decrease. And if temperature is less, let's say temperature becomes 0 degrees Celsius and it is very cold outside, a very large amount of people are going to buy heater. And as temperature becomes better, temperature becomes uh, less cold, the sales of heater will suffer losses. And therefore, this is an example of negative correlation. Similarly, let's take another example. Another example is number of sleep hours. So on the days when you sleep more number of hours, you are likely to experience less tired, less sleepy, right? So let's plot tiredness on y-axis and sleep hours on x-axis. As the number of sleep hours increase, your tiredness decreases, and as the number of sleep hour decreases, your tiredness increases. So students, thanks for joining today's class. We will discuss more aspects of correlation in the next class. Thank you, everyone.